All right, so this is the second attempt at posting a video. I got kicked out of my account yesterday, but today we're going to be talking about volume and surface area. So we're going to just take notes today, go over a few vocab words that we'll use throughout this unit, and get an idea of what new shapes we're going to be working with. The very first shape we're going to be working with is actually called a polyhedron. And so a polyhedron, instead of the two-dimensional shapes we have worked with before, like it says here, copy these definitions down. It is a three-dimensional object with no holes that is bound by polygons. So down here, the four shapes that are called prisms, these are also examples of polyhedrons. So all of the faces, all of the parts of these shapes are made up of polygons. They are all straight lines and they're all enclosed shapes. A little bit more specifically, though, these are also prisms. So they are a type of polyhedron, but they have two congruent and parallel. So keep an eye on this. They have congruent and parallel faces that are called bases. So there's two of them. Each of these down here under examples would be considered bases. So the ones that I've highlighted right here, those would be bases. These would be bases. And in the case of this next one, you could say that these two parts are the bases, but you could also argue, since it just needs to be congruent and parallel, that this and this is a base, or even the back side and the front side. A little bit harder to see that example, but those are all considered bases. And then lastly, we've got the triangular prism that has two congruent and parallel bases. So notice that all of these are referring to the two congruent and parallel bases. That's actually how you name the prisms as well. So notice on the first one, the pentagonal prism, the reason it's called that is because the two that I'm highlighting right now, these two faces, are pentagons. And so that's how we're always going to name prisms. In addition to that, so we've got the two congruent and parallel bases, we also have the lateral faces. So that's everything else. So on the first example, again, the pentagonal prism, that would be everything along the side. This part right here, basically everything except for the bases. And so the stuff that I don't highlight, I guess, from those first areas. And that's going to come into play when we calculate a few other things regarding surface area and volume. But these are just some examples of the prisms that we'll work with. If we had a prism that had, let's say, a base that was a decagon, you could call that a decagon prism because that is the base shape. One thing, though, if you have a circle as your base, instead of calling it a circular prism, we're actually going to be calling it a cylinder. The reason for that is polyhedrons are made up of all polygons, but a cylinder is actually not a polyhedron because a circle is not a polygon. So the reason for that is those round edges, but this right here would be our definition for a cylinder. It's like a prism, but it has circular bases. Another three-dimensional figure. Everything we've worked with up until this point has been two-dimensional, but now we're getting into some more types of shapes. Notice that I have two kinds of cylinders here. I called a vertical cylinder and then a horizontal cylinder. It doesn't matter what the orientation of the shape is. It's more important that you have two congruent parallel bases. So just like in the case over in the prisms area, there are two examples where the base doesn't have to be top and bottom. So sometimes base is not top and bottom, or sometimes the shape is horizontal instead of vertical. So that can happen with the prisms, it can happen with the cylinders as well. Just to keep in mind that the orientation is going to be different in some cases when you're trying to calculate certain things. So that's just a little bit of the vocabulary, some of the figures that we're going to work with. If you haven't taken notes on this yet, this is part of the notes. So make sure that you pause the video or take a look at the PDF and copy this down. So you'll know what we mean when we talk about prisms and when we talk about cylinders. So now that we've gotten that, a couple more definitions: volume and surface area. So these are the main two ideas that we're going to be working with when it comes to chapter 9, volume and surface area. Like it says here, volume is the amount of three-dimensional space that a solid figure occupies. So think about how much three-dimensional space. We would measure that, just like it sounds, in cubic units. So in the videos we've watched in the past, that would be considered three different measurements that we're using, cubic units. So that would look something like feet to the third, or inches to the third, and so on. So the reason for that is because we're taking the base and the height, but also the depth. So three different measurements. So with surface area, we're adding up the area of all these surfaces of a three-dimensional solid. If you want to think about it, it's almost like how much area you would need, or how much area it takes to paint the entire outside. Let's say we're painting it. It would take to cover the solid with paint. And it would be the outside of the solid, actually. So let me take that back. How much area it takes to cover the outside of a solid with paint. And since we're only covering the outside, not filling it with paint, that would be volume, we measure this in square units. So this is what we've used in the past. We measure that in square units. So that would be feet squared, inches squared, and so on. And these are the two that we're going to be using to create an idea or a measurement for these three-dimensional figures. The only thing we need beyond that is a couple formulas then. So the first two formulas we're going to work with are actually going to be for the volume and surface area of prisms. So the first one, let's call this formulas. The volume formula. We'll call it volume first. I'll zoom in a little bit so we can get a better look at this. Just like how we used to figure out volume, let's just take a look at this shape right here, actually. So this is an example of a rectangular prism, a three-dimensional solid. We used to just count how many cubic units there were. So that was what the last video showed an example of. You take the three measurements and you multiply them. So we have the height right here, we have the width right there, and then we have the depth right here. 1 unit, and 1 unit. That's a cubic unit. So instead of counting how many of these cubic units there are in the shape, we can actually multiply a few things to figure this out. So if I wanted to find the volume, the definition that our book uses is the area of a base, the area of one base and we multiply that by the height of the three-dimensional figure. So these two things, let's call this the area of one base, and then we'll call the height, or we'll color it this way. So the area of the base times the height. If those are the two things that we're working with here, area of the base and the height, let's look at it this way. The area of one base would be everything I've covered in green right here. And since we can see that this is going to be 3 by 4, we know that the area is going to be 12 units squared. And then we have the height of this figure. So the height in this case is going to be 2 units. So when we take that height, 2 units, and multiply it by the area, that actually gives us the volume. So if we were to write that out, let's go ahead and calculate the volume of this figure. Area of the base is going to be 12 units squared. And then we're going to multiply that by the height, which is 2 units. Notice that the height is just a one-dimensional measurement. It's just that 2 units that we measured in blue. Once we multiply these two, though, we end up with 24 units cubed to the third power. That's because we have 2 units right here and 1 unit right here. Once we multiply all those, we have cubic units. So that gives us our area, our volume. Now that we have our volume, that will be our final answer for that. So that is our formula for volume. Now when we get to our formula for surface area, it's a little bit different. There's a few different ways that we could do this, but the easiest way or the easiest formula that we could come up with is adding up all the faces of the figure. So what that looks like, if we were to, and let's get this cubic units out of the way here. If we were to take the surface area of this shape, notice that there are 3 different sets of faces. We have that base, that one base that we already measured the area of, that one in green. And notice that there's got to be one on the bottom too, kind of where I've colored right here. So since we know that there's 2 of those, I don't have to find the area again. I know that there's 12 units on top and 12 units squared on the bottom. So that gives us 2 of our faces. So I'll kind of draw out each of these sets. I know that we've got 2 of these 4 by 3 faces. And then if I were to, and in fact, you know what, I'm going to color this in a different color, just so that we can get an idea. Since we're working with green here, we've got 2 of these 3 by 4s. And then we've got another face. Let's go with this one right here. Notice that we have the one on the right, and then there would be another one right here. Again, since there's 2 sets of everything. I'm going to get that out of the way just so we can visualize this, though. So now that we've got that one, that means that we've got a, let's see, 2 by 4 face. So that means that we've got something like a 2 by 4, and there's 2 of these. And then the last one, let's call this the third set of faces, is this one right here. So that's going to be the last one that we're working with, and that is a 3 by 2. So I'm going to just use red for this one. And we've got a 3 by 2, and there's 2 of these. So now we've got the area for these 3 figures that make up the 3-dimensional solid. This is 12 units squared. This 4 times 2 is going to be 8 units squared. And this 2 times 3 is going to be 6 units squared. So surface area is going to be all of these 6 faces total. We've got 2, 4, and 6 faces total added together. So when I figure that out, we've got 12 units squared times 2. In fact, I'm going to put the 2 up in the front. So we've got 2 times that plus 2 times 8 units squared plus 2 times 6 units squared. So that's going to be everything added together. So now we've got 24 units squared. And then we've got our 16 units squared. And we add the last part, which is our 12 units squared. All of these square faces added together gives us our volume, which is going to be 24 plus 16 plus 12. It looks like that would be 52 units squared. Again, that's measured in square units. So that is our final answer for the surface area. So since we have those two measurements, that's our first example. Quite a bit of work for just that three-dimensional figure. So if you haven't, make sure that you highlight all of this in yellow right here. This is the important part. So we've got our volume and our surface area definitions. And then we're going to move on to a couple more examples before we wrap up the notes. Coming down here, again, if we're trying to find volume and surface area for a couple more examples, let's start with volume. Back to our definition, there's 2 things we need to find. We need to find the area of one base, and we need to find the height. The height is just the distance between the 2 bases. So if we want to find the area of a base, first we need to figure out what are the bases. The bases are the 2 faces that are congruent and parallel. As nice as it would be for this right here to be our base, you would need another one on the other side that is congruent and parallel, which we don't have. So that wouldn't work. So the rectangle doesn't actually work. Same goes for this nice rectangle right here. If that was a base, then there would need to be another one right here. So none of the rectangles are actually going to work. We actually have to work with instead this triangle right here. So this triangle is our base because there's another one across the way. We know that these 2 are congruent and parallel. So because of that, this is actually not a rectangular prism. This is a triangular prism. The area of our base is going to be the equation for a triangle's area. And then our height is going to be the distance between the 2 triangles. So since we know that, there's only 2 things that we need to find. This is our height right here. We actually already have the height. That is right here, the distance between our 2 triangles, 3 feet. The area of our base, though, since we see this right angle right here, we can actually figure out the area of the triangle pretty easily. The area of the triangle is going to be our base times height, so that's the 3 right here, times the height 4 divided by 2. So base times height divided by 2. So once we figure that out, 3 times 4 divided by 2, area of our base times our height, which is 3 feet, we can find our volume. So this is going to end up being, let's see, 12 right here divided by 2. So we get 6 feet squared is actually our area of our base times that 3 feet, which is the height, the distance between the 2 bases. When we multiply these 2 together, we get 18. And instead of feet squared, since we're working with volume, it's going to be 18 feet cubed. So this is our volume. And I'll just kind of write this right here so that we know, although it is implied with that cubed measurement right there. So now that we have our volume, the next step is the surface area. And again, the way I like to keep track for surface area is by adding up all the faces, right? So since we know the area of one of our bases, we'll call that our triangle right here. So this has an area, since we already figured it out earlier, of 6 feet squared. We know that there are 2 of these. We have 2 of those. But in this case, there are 3 different rectangles that we also need to find the area for. We have the one up top, so let's call that this one right here that I'm measuring in blue. So that one is going to be our 3 by 3 rectangle. 3 by 3. And there's actually only one of these. The next one that we can find, let's go with another color here. This one right here is this triangle on the right-hand side. So that one is going to be 4, or sorry, not the triangle on the right-hand side. I'm trying to get the rectangle on the front side. So this right here, that is going to be the rest of the front side. So that's actually going to be 4 times 3. So that's another rectangle that we're working with. So once we get that, 3 and 4, we know that there's one of those. And the last one that's a little harder to see, I'll actually have to erase a few things so that we can see what I'm talking about. Dun, dun, is going to be this face right here, the one that would be on the sort of back side of the triangular prism. That's going to be that 5 units right here and the 3 units across. So it's that kind of slanted rectangle face. That's going to be the last one that we're working with. So that's actually 5 by 3. And again, there's only one of those. So if we can find the area of these 3, again, it's just a quick calculation. 3 times 3 here is going to be 9 units squared. And then we've got our 4 times 3, which is going to be 12 units squared. And our 5 times 3, 15 units squared. We've got one of each of those rectangular faces and then 2 of the triangular ones. So I'm going to take this 2 and multiply it by our 6 feet squared. I'm going to add 9 units squared, add 12 units squared, and add 15 units squared. All of this added together, so 12 feet squared plus 9 units squared plus 12 plus 15 is going to be our surface area. All of the paint that we would need to cover the outer surfaces. So when I add all of this together, I'll use my calculator. 12 plus 9 plus another 12 plus 15. The surface area is 48 units squared. Again, we're measuring in units squared for the surface area. And I will actually label this. Again, though, we know that it's surface area because of the units squared. So quite a bit of work again, but we have our volume and our surface area for this triangular prism. Lastly, we have a cylinder. A little bit different because of the surface area calculation. That'll be something that we actually get into later on next week. We're just going to be calculating the volume for this figure today. So when we do this, to find the volume, it's the same as you would calculate for any of these other shapes. you want to take the area of one base and multiply it by the height. Think about dragging this green base all the way down to where the other base is and how much space that takes up, how much three-dimensional space that takes up. So down here, our volume is going to be the area of our base, which from last chapter, we figured out is going to be pi r squared, that's the area of our base, times our height. And our height is something that we'll have to find in this figure as well. So our radius is 5 units squared, or 5 inches squared in this case. And our height is equal to 4. That is this distance right here. So that's what this 4 is measuring. So to calculate our volume, I'm going to take pi, multiply it by 5 squared, and that's going to end up being 25 pi. So that is our area of our base, and our height is just that 4 inches. So now we've got 25 pi inches squared times 4 inches. That is our calculation for the volume. When I multiply these together, you can leave it in terms of pi, so I can multiply the 4 and the 25 together. That ends up being 100. Then I need to bring that pi down, and then I need to bring all of the inches down. So inches cubed. So a little quick, but that is our, that purple is a little hard to read with. So that is our volume right there. We actually already found our volume. 100 pi inches squared. Or sorry, inches cubed. Almost messed that one up. The other calculation, if you were to multiply out the pi, would be around 314 inches cubed. Both of those answers would be acceptable. But now we have a better idea of calculating how much three-dimensional space each of these solids can take up and working with some of their surface areas. Next week, we'll talk about surface area of a cylinder and work with some more difficult examples regarding volume as well. So make sure we have this copied down. You can rewind the video or check the PDF to get your notes down. Tomorrow we'll get a little bit of practice going for the video. But that is all for today. Have a good rest of your day.